Alright, we now move on to topic 4, that is transient circuit. Transient. Now, transient, when we analyze this topic, there are actually two types of circuit that we want to analyze. They are the RC circuit and the RL circuit. Okay, that means R resistor with capacitor or resistor with inductor. Okay, let's start with RC circuit first. Now, for RC circuit, there are a few things that you need to know. One, the formula is time constant. Right? This is called time constant. And this is the symbol we write for time constant, a curly this and then like this. Right? Looks like a T actually. So the English word is called time constant. Okay? And the formula for time constant is equal to R times C. Okay, and the units of course is second. Yeah? And secondly, we need to know that there are two kinds of formula, which is called VC, can be E bracket 1 minus E minus T over time constant, or VC is equal to E minus T over time constant. Now I want you to recognize this without explaining to you what they are. One, this is an exponential function which you have learned in your mathematics, right? And this is with a bracket. With a bracket is an increasing function. So in other words, if I were to draw a graph for VC versus time, right, this is an increasing function. In other words, you increase and then go to a saturation, right? Whereas this one, this exponential function is without a bracket. Without a bracket is a decreasing function. It's a decreasing function. So when I say an increasing function, I want you to have the diagram or formula in your head is actually a mathematical expression with a bracket, increasing function. A decreasing function is without a bracket. And increasing function means the value is going to increase. Decreasing function means the value is going to decrease. Alright, so that's the first thing I want you to know, the time constant formula. Secondly, the expression, and increasing function and a decreasing function. Right, the next I want you to know is about phi time constant. Now, phi time constant is actually a duration of time. Say, for example, if the time constant is equal to 7 seconds, then phi time constant is equal to 5 times 7, that is equal to 35 seconds. Now, the meaning of phi time constant is actually the time needed, for the circuit to achieve steady state or to arrive at steady state. Alright? Now what's the meaning of steady state? Steady state means finally, the final value. Okay, we'll talk about it later. Okay? Alright, so we have already gone through a few terminology that I want you to be familiar in transient topic. Yeah? What are they? If you could recall, I started with the English word, the formula called time constant. Time constant is what R times C, so it's actually a value, right? So let's say the resistor is 3 kilo ohm, the capacitor is 6 microfarad, then is equal to 3 times 6, 18, so 18 times 10 power 3 times 6 times 10 power minus 6, so I actually get 108, 18 times 6, correct, it's 108, so it's 108 times 10 power minus 3 seconds. So it's 108 millisecond. Okay, so this is called a time constant. So that's the first thing I want you to know. Secondly, I went through to say if it's an increasing function, if this is an increasing function, the voltage across the capacitor is an increasing function, I expect you to come up with an expression for me with a bracket. Alright? Say for example, I can give you an example, like say VC is equal to 20, 1 minus E minus T over 108 times 10 power minus 3. You see my example just now, the time constant was 108 milliseconds. So this is a mathematical expression for an increasing function for voltage across the capacitor. Okay? And then I also say that if it's a decreasing function, you know that this voltage is decreasing, then it is without a bracket. Alright, so using an example, this is an example. So it's 20e minus t over 108 times 10 power minus 3. Alright, volts. Of course, voltage. So this is the second thing that I need you to know. And the third is a shortcut formula called phi time constant. A circuit to reach steady state, it takes phi time constant for the circuit to reach steady state. Right? So example of my time constant just now, example, phi time constant is 5 times 108 millisecond. Right? That was the example that I gave just now. Okay, so that's the introduction without any explanation about what transient is all about. Right? Can you remember what are they? The formula for time constant is R times C. If it's an increasing function, mathematical increasing function for a transient circuit, is with a bracket. A decreasing function is without a bracket. And the third is about phi time constant. Okay, it's a magical formula for you to calculate the total time takes for the circuit to reach steady state. Okay, right. So with that, we now move on to the proper of the transient RC circuit. Now, if I have a DC power supply with a switch closed open and a resistor and a capacitor, right? If I say this is 20 volts, right? This is 4 kilo ohm, this is 6 microfarad. Capacitor, the units for capacitor is 6 microfarad. This is a switch, and I'm going to close the switch at t equal to 0 second. Okay, alright. Now, before the switch is closed, actually it was open. Alright, and the capacitor was initially uncharged. In other words, it's just like your handphone battery that you have used it for the whole day long, and then now it's no more battery. You don't do anything with it. So the voltage across the capacitor is equal to 0 volt. Is equal to 0 volt. Right? Now when I close the switch, I'm actually pumping current into the circuit, right? And your capacitor is going to be charged. So it's just like your handphone to be charged. So the voltage here will increase, right? As the time goes, it becomes 0 volt, then become 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. Eventually it will go on to 20 volts. Right? So that's what we mean that the capacitor is being charged. When it is fully charged, the voltage is 20 volts. Right? Initially when it's uncharged, it's 0 volt. Okay? Now let's think about our mathematics. If Vc is equal to 0 to 20, is this an increasing or decreasing function? Obviously it's an increasing function. So if I were to write a mathematical expression for my Vc, that is equal to E bracket 1 minus E minus t over time constant. Now my capacitor is going to charge up to 20 volt because the voltage that I subject to the circuit is 20. So it's 20, 1 minus E minus t divided by my time constant. Now what is my time constant? I have to calculate the time constant. So I say time constant is equal to R times C. So it's equal to 4 kilo multiply 6 micro. So that's equal to 24 millisecond. I know my mathematics, alright? Of course, you use a calculator to come up with the same answer. So then I will substitute back into my expression. So it's 1 minus E minus t divided by 24 times 10 power minus 3 volts. So that is my Vc. So that's the expression for Vc. Okay? Alright, so we understand this. Let's go and talk about our voltage across the resistor. VR. Right? Now, when here is 0 volt, when the voltage here is 0 volt, okay, let me erase all this. When here is 0 volt, here is 20 volts. Because Kirchhoff's voltage law says 20 is equal to 20 plus 0 is equal to 20. So when here is 1, here will be 19. When here is 2, here is 18. When here is 3, here is 17. So as this increases to 20 volt, here decrease 20 to 0. Am I right? 20 plus 0 is 20, 0 plus 20 is 0. So can I therefore ask you, the voltage across the resistor is increasing or decreasing? It is a decreasing function, right? If it's a decreasing function, then I ask you, should I write the bracket or without the bracket? It will be the one without the bracket, right? So it should be E minus T over time constant. So in other words, now this becomes 20 E minus T over time constant, and my time constant is 24 milliseconds. Okay? Right. So what I've gone through with you is the story about the voltage across the resistor and the voltage across the capacitor. Okay? Let us revise it very quickly. Before my switch was closed, it was open, alright? And my capacitor is initially uncharged, so the voltage is 0 volt. When I close my switch, the voltage here, the capacitor is being charged, it will go from 0 to 20 volt, right? And we know that this is an increasing function, so it is with a bracket. Alright, so the voltage finally is going to charge up to is 20 volt, and the time constant is 24 milliseconds. And the voltage across the capacitor, while this one is increasing, this one is decreasing, right? So it is 20 volt to 0 volt. So it's a decreasing function, so it's without bracket. Okay? Alright, so now let's talk about the current through the capacitor. This circuit, I. Okay? Now if I were to calculate the I would use V over R, right? Ohm's law. Ohm's law says if I know the voltage, I know the resistance. Voltage divided by resistance, I give current. So my voltage is a decreasing function, 20 E minus T over time constant, divided by my resistor 4 kilo ohm. So that's the current. So when you look at this current, is this an increasing function or decreasing function? It is a decreasing function because it's without a bracket. So in other words, the current finally will become 0 ampere. This is a decreasing function. Finally, it's going to become 0 ampere. So the I is going to be 0 ampere finally. Right? And that is why we say, therefore we say, when capacitor is fully charged, I is equal to 0 ampere, no more current. Therefore, it acts as open circuit. So you will notice that in your notes, you constantly come across this word to say that capacitor acts as an open circuit when it's fully charged. Alright? So it means no more current flowing through it. How long? If you still recall, it takes 5 time constant. So for this circuit here, our time constant is 24 milliseconds. Right? So how long would it take for it to become 0 ampere? That means no more current flowing through. Then it will take 5 time constant. 5 time constant is 5 times 24 milliseconds. So that is equal to 120 milliseconds. So in other words, to say, after 120 milliseconds, the current becomes 0 ampere. Right? If I were to ask you to sketch the current and the time graph. Okay? Alright, let's look back to this circuit here. Alright, so if you understand what I've said, let us quickly recap the story. Okay? I have a series circuit with a battery of 20 volts, with a switch that's initially open, a resistor with a capacitor. Resistor is 4 kilo ohm, this 6 microfarad. Capacitor should be drawn this way. Right? So this is my R, this is my C. Okay? Right. So part A, I ask you, what is the time constant in this circuit? Okay? So you say, oh, the time constant is R times C, so it's equal to 4 kilo multiply 6 micro, so it's 24 milliseconds. Right? Part B, can you write me a VC expression? right? Write me an expression for the voltage across the capacitor. Then you say, okay, you understand that initially was uncharged. So it is from 0 to 20 volts. So it's an increasing function. So you say it's with a bracket. So you say this is the expression. Alright, so you say, okay, my E supplies 20 volt. So it's 21 minus E minus T over 24 millisecond. So that is the expression for the VC. Part C. Find me the expression for VR, the voltage across the capacitor. Then you say, okay, K, according to Kirchhoff's voltage law, if here is 0 to 20, here should be 20 to 0. Right? So therefore, it's a decreasing function. If it's a decreasing function, right, VR is equal to 20 to 0 volt. If it's a decreasing function, then it is without a bracket. So it's E minus T over time constant. So it's 20 E minus T over 24 millisecond. Right? Then I say, give me an expression of the current. The current expression. They say, okay, current is equal to voltage across the resistor divided by resistor. So it's 20 E minus T over 24 millisecond divided by my resistance. Okay? Alright, part E. How long would it take? How long would it take for VC to be 20 volts? Then you say, oh, the shortcut, 5 time constant. So it's 5 times 24 millisecond. So it's equal to 120 millisecond. Right? Shortcut. Yeah? Okay, part F. Can you find out the time? Can you find at T is equal to 40 millisecond? Can you find VC? No problem. I've got the expression. What I need to do is just substitute the time into the expression and use my calculator. I can get the answers. So I say VC is equal to 21 minus E minus T over time constant. So it's 21 minus E minus 40 milli divided by time constant is 24 milli. 24 milli. Right? So with that, and I use my calculator, I should be able to get the answer. Right? Should be able to get the answer. Okay? Part G. Can you find out the time? What is the time when VC is equal to 14 volt? Okay, it's still a mathematical problem. So I write VC is equal to E expression. Okay, E bracket 1 minus E minus T over time constant. Right, so you see here it says 14, so I write down 14, 20, 1 minus E minus T divided by 24 milli. One equation, one unknown. Can this unknown be found? Of course it can be found if you use your calculator. Yeah? So that is that. Okay, then we move on to say, can you sketch the graph? Right, part H. Can you sketch the graph of VC? Sketch VC. Okay? So this is VC and this is time. And if you look here, VC is the increasing function. So you must increase. So you increase from 0 volt to 20 volts. 20 volts. Right? And how long does it take? 5 time constant. And 5 time constant is how much? It was 5 times 24, so it's 120 millisecond. Right? Part I. Can you sketch VR, the voltage across the resistor? Voltage across the resistor is a decreasing function, so decrease, right? From 20 volts to 0 volt, right? How long does it take? 5 time constant. Okay? Part J. Can you sketch the current? The graph for the current. Current again is a decreasing function. So it's a decreasing function. Right? Again, here is 5 time constant. Right? The value, of course, the maximum value will be the value that we calculated just now. Yeah, 20 divided by 4K. Okay? So that is a gist of what charging circuit is all about. You get the story? Alright? Okay.